Hi, this is video lesson number 4 for Unit 2. Today we're going to be talking about solving triangles as well as finding angles of elevation and depression. You can see in your notes packet that I've written a little bit to you. Before we get started, please make sure that you have your calculator handy. So if you don't, please pause the video and go get your calculator. At the start, I've written this to you. To solve a triangle means to have found all of the angle measures and all of the side lengths. So there are in total 6 different measures that you would know if you have in fact solved a triangle. It is typical that when we are labeling a picture solving a triangle, the 3 points or the corners, here, here, and here, are all labeled with a capital letter. And so let's say that this is capital A, this is capital B, and this is capital C. And then it is typical to then use the same letters, but lowercase, for the sides that are across from each of those angles. So here's angle A. Across from angle A, we'd put a small a. Across from capital B, we'd put small b. And across from C, we'd put small c. And that's a little hard to tell with the C's because they're kind of the same shape of, when you're writing it by hand. So just be aware of what things are what. And it's easy to be aware because you know that capital letters go with angles or points and lowercase letters go with sides. When it's really important that when you solve a triangle, you do 2 things to be accurate. You try to, first of all, go back to the given information as much as possible. If you did the problem, like say you did a part of the problem, and you got that part incorrect, and then you used that part in finding yet another part of the answer, you would be spreading the poison. Okay, so what I mean is if, say, there were 2 things you needed to find, and the first thing you found out something was equal to 5, but it really wasn't because you made a mistake. And then you used that 5 to find the next thing, this is also going to be wrong. Okay, so try to use the given as much as possible, unless you are incredibly confident you have made no mistakes. And then the second thing is you only round your answers. You do not round your steps. So if you, again, going back to this idea of using one answer to determine another, if you're in the middle of a problem and you have a middle step that's equal to 5, actually it says on your calculator it's 5.13798, but you decide to just call that 5, you're going to lose some accuracy in your answer. So keeping that in mind, let's try some of the examples now. The first one says solve the right triangle. This is actually a little bit of information. It's telling us we have a 90-degree angle. And you see that is written actually right here as well. Solve the right triangle ABC with these measurements. So I'm going to draw out the right triangle. It says that C is the one that is 90 degrees, so I'm going to mark that. I'm going to call this A and write 58 in it, because that's what it said in the problem. And then this is a lowercase letter, so I know it's a side. And it's a C, so it has to be across from capital C. So this must be where the 748 comes in. And since it said the triangle is ABC, this missing side must be, or missing point must be B. And then I can label the sides, little a and little b, to match up with the points across from them. Can you tell me what this angle would have to be? Hopefully, figure out that it is 32. How do we know that? Well, the 3 angles in a triangle have to add up to 180. Furthermore, if this is already 90, that means the other 2 angles, A and B, have to add up to 90. So putting all of that together is how I got my answer. All right, now that we know that this angle is 32, I'll also put that in the picture. But notice I'm using a different color, and that is very intentional. It is because I want to make sure that I keep track of which parts were given versus which parts I figured out in order to try to be as accurate as possible. Okay, now I'm going to use some SOHCAHTOA stuff. Okay, I'm going to say, well, I know this angle is 58. I'd like to know this side. I do know this side. So if I try to connect what I wish I knew with what I do know, I can see I want to use sine here because A is opposite the angle 58. So sine of 58 has to equal opposite over hypotenuse. I'm going to put a 1 here, and then I'll cross multiply. Okay, get your calculator. make sure you're in degree mode and type that in. Okay, you should have gotten, and make sure that you do, because otherwise this is, if you're not getting these right answers, it means you're doing something crazy on your calculator. And so we need to figure that out before we take a test and have crazy stuff all over your test. But this is what I got. I do believe that it's a good rule of thumb to just include 3 decimal places of accuracy. I never see a need for us to be more accurate than that. Okay, so there's our answer for what side A is. I'm going to put that into our picture. Oops, I didn't mean to pick you up. That's not really a great choice. This is 634.340 to 3 decimal places of accuracy. Now I want to find side B. So how about I do the same sort of thing? I'm going to use the 32 this time. Actually, it'd be better if I used the 58, wouldn't it? The 58 was given. So let's use the 58. I take that back. Let's get that arrow out of there. Okay, let's use the 58 again because that was given in the problem. So let's find B using some given information. So let's do cosine of 58 would have to equal B over 738. And then we do that cross multiplying just like in the previous part. Now it's just cosine instead. Sorry, my handwriting's kind of poor there. Alright, now type into your calculator and see what you get. So start with a 3. I hope so. It should be this. Okay, make sure that you can get that on your calculator again. We want to find mistakes before our unit test. Okay, our next question. We want to make sure that we have a good picture. So, I'm not really sure what I just did there. Okay, so we're going to make a picture. It says that C is 90, so I'm going to put my right angle here. These are both lowercase. What does that tell you? Hopefully that tells you their size. So, oops. So this is 368. I put capital A here. This is 130. So you might have another idea here about how to find our third side. I hope you do. It's not even anything with SOHCAHTOA. It's just good old Pythagorean theorem. So if we do the Pythagorean theorem, we should be able to find that missing side, which is the hypotenuse. We should get 90. Okay, let's just make sure that we know how to do that on our calculators, okay? Lost track of where my calculator is on the screen. Oops, I bumped something. Here it is. Okay, so 130 and 368. And here we go, and then the square root of that answer. Okay, so there were the decimal places. I didn't write that down on my own notes, so I better write that down now. 287. Come on, buddy. Okay. Alright, so there's my answer for C. And now I need to go back to finding angles. So I'm going to find angle A. Okay? And I'm going to try to use just my given rather than the number I just got in case that happens to be incorrect. Okay, so opposite and adjacent means I need to use tangent. Okay, so now you need to remember all that calculator stuff we talked about. To find angle A, I need to use inverse tangent. 130 over 368. So inverse tangent. Wow, short-term memory loss. And where did that screen go? Oh, this is not good. Hold on. Okay, sorry, little momentary panic. Something disappeared for me and I found it. So, inverse tangent, okay? You just type this in and then we get that our angle is 19. This is what I don't like, because if I start writing there, then the calculator goes away. That's not cool. 19,456, okay. Right, and then to get angle B, all we would do is understand that the angles have to add up to 180. So all I need is to find the complement of 19,456. So I could just make sure that it adds up to 180. And that would give me 70.544 degrees. Okay, next one. Last one on this side. Looks like it's missing something, but the directions up above do mention that I have a right triangle. So I'm just going to say that C is the right angle, like in the other ones. Could have been A, but I'm going to say C. Let's say this is angle B, so this is 48, which means that this has to be 42, right? We're adding up to 180, so I already have C is 90, A is 42. Figured that one out. And now we need to find some sides. I do know that this side is 299. Okay, I'd like you to pause the video and then come back and check your answers, okay? Please do the problem first to make sure you're on track. Okay, welcome back. You should have these. You should have found a couple of answers. You should have found this number and this number. Over here I have setups. You can just check and see how you did it. The last part of our lesson is about angles of elevation and depression. And these are very similar ideas. The only distinction between elevation versus depression has to do with whether you're looking up or looking down, okay? So if I've really been thinking ahead of it, depression, let's color code that, okay? So elevation is going up, depression is going down. And they're going up or down from a given line, and that given line has to be horizontal. That's the thing that people forget. So notice I put that in bold, and we are going to emphasize the heck out of that, okay? So we always are measuring from the horizontal how far up or how far down. That's the key. All right, so let's do a couple problems. First one. Julia is standing 50 feet from a building, so I will use my awesome drawing skills, JK. I will use my skills to try to draw this. So we have a building. Here's her building. Here is the ground. And Julia is standing over here. This is definitely not to scale because look how tall Julia is compared to that building. Anyway, so Julia is standing 50 feet from a building. So this distance is 50. The angle of elevation from her eyes as she looks at the top of the building is 75. Now Julia, if she was looking straight ahead, this would be like her line of sight, but she's looking up instead. This angle is the angle of elevation, and that angle is 75 degrees. Wow, really, really not drawn accurately in terms of measurements, but it will be good enough for us to do the problem, okay? Her eyes are 5 feet from the ground. Okay, so this distance here is 5, which means that is also true over here. That's also 5. Okay, you're supposed to figure out the height of the building. First, let's figure out the distance from this black dot to this black dot. That distance, let's call that x. This dotted line that I just blackened in is also 50. So if you focus on the center part of the picture, right in here, oops, I don't really want to use that color. Let me go back here. I already used that color somewhere else. Here. This triangle is what we're going to focus on, okay? So we just need to we need to do some math. We need to say x is what I want, 50 is what I have, so opposite over adjacent is tangent. Tangent of 75 equals x over 50. So x is going to equal 50 times the tangent of 75 degrees. So on your calculators now, let's do that. 50 times the tangent of 75. And I got 186.603. But that's not quite our final answer because there's this little bit down here on the picture. See that? Look right there. 5. So we need to add the 5 feet for Julia's height, so to speak, or the height of her eyeballs anyway. And so I would say for 3 decimal places, the height of the building is 191.603. Okay, last one. A plane. I'll be very amazed because I'm so good at drawing. This plane is going to look amazing. Just kidding. A Okay, a plane is 3 miles above the ground. So here's the ground. The plane is 3 miles up. So this distance is 3 miles. Okay, the pilot's in the plane, and he or she is going to look down and see an airport. Looking down, there's the airport. The pilot's looking down at an angle of depression of 15 degrees. Now the thing is, a lot of folks will make a mistake right at this point because you have what looks like a triangle, and they put the 15 degrees inside the triangle, but they put it in kind of the wrong place because remember, we measure these angles of elevation and depression from a horizontal. Here's where the pilot is. Okay? The pilot would normally be looking along this line of sight. That's the horizontal you want to use. So the slanty line of the pilot's sight as compared to the regular line, that's the angle that's 15. If that angle is 15, from geometry, you learned that when you have this kind of shape, with a line that crosses it, these two angles are congruent. So since that angle's 15, this is also 15. Now that is not where the pilot is, but it happens to be an angle that's also 15 degrees. We're assuming that we have a 90-degree angle here. That's how you'd measure the height of the plane would be perpendicular to the ground. So we really have this nice little picture. I could just make a smaller version that looks less complicated or crowded, and this is what we've got, okay? And then we are supposed to figure out the ground distance between the plane and the airport. The ground distance would be along here. So we just have to do one little SOHCAHTOA problem. I want you to pause and come back and see your answer. See if it's right. Okay, here's my work. I found out that the airport and the plane by ground distance are about 11.2 miles apart, and here's my work, okay? Compare that and come to class ready to work on problems like these. Thanks.